Thank you very much, Tony. Thanks to the team at Dassault Systems headed by Bob for these two presentations. For those of you who have any further questions about the capabilities of CATIA version 6 and the compatibility with CATIA version 5, we actually have a series of success stories. We produced a global digital magazine called Contact Mag, and recently we updated it as a special edition for transportation. We do have a copy here that you can refer to, but if you'd like a digital copy, again, just send an email to me, paul.silver@3ds.com. We're glad to get that to you. I saw many hands go up when I asked if there are any new attendees here. We want to make sure that we capture you and get you on the distribution list for all future meetings. I'll be sending around this sign-in sheet. We're just going to ask for a few brief details, your name, your company, your phone, and email. Oh, great. Oh, well, no problem. We'll stall a little bit further. So as this reboots and restarts, which should really be only momentarily, hopefully, we're just going to ask for your essential details. We'll add you to the database. Also, I'm going to encapsulate a few additional announcements while we're waiting for that. Just kind of take all the details all at once instead of spreading them out in between speakers. We do have a series of bi-monthly meetings. First, for those of you who are new to the equation, CATIA Operators Exchange, is one of the largest and oldest organizations in the world, focusing strictly on CATIA users, ever since the inception, really. It's the largest and oldest group in the world. Here, GLACO in Michigan is the largest and oldest regional users group. So the CATIA Operators Exchange at the national level supports upwards of 7 major user groups. Here we have the largest and oldest. We'll have our 25th anniversary next year. And we have just recently relocated. Previously we were at the OCC campus. Now we are here permanently in the foreseeable future. Keith Nagara does such a great job here, and this is a phenomenal gallery facility. And it's been very successful. I think we're going to be here from now on. So that you can mark your calendars. We do have another meeting later this summer. It is bi-monthly, so logically the next one's going to be August. It's going to be the 3rd Tuesday of August, August 21st. If you can make a note, we'll also be sending you an email as long as you sign up. On the 21st, it'll go back to our half-day schedule. We won't abbreviate our meeting schedule, and we'll have featured speakers from our next business partner sponsor, as well as from Dassault Systems. We also wanted to thank, for his participation today, Jeff Rourke, who is the president of our partner organization on the west side of the state. Here we're GLACO, on the other side of the state, the Western Michigan CATIA User Group, or WMCUG, something like that. Better remember just as Western Michigan User Group. They are located at Ferris State, just north of Grand Rapids, or in Grand Rapids?
It's in downtown campus.
Phenomenal. Downtown campus there.
Grand Rapids.
Okay. Whereas we go every other month, the 3rd Tuesday, they go every other month, the 2nd Wednesday. The next meeting then is September 12th. They take a little bit of a summer break, well deserved. They also have a series of partner sponsorships there, as well as Dassault Systems and other partner support. A lot of great topics and free training and demonstrations. So please take advantage of that. Also, I'm going to be sending around this sign-in list. Usually from the sign-in list, after every meeting, we have the time to ask some trivia questions based on the presentations. Really no time for that today because we've got a phenomenal slate of OEM speakers, thanks to Phil Bouchard and the CATIA team, as well as Keith Nagara. So we won't be doing that, but we still want to make sure you're in the distribution list, so make sure you sign up. Also, we do an informal survey by email and by show of hands at every meeting. We're also going to be, since this meeting has been extended for most of the day, I'll be networking with you at most of the breaks. We do want to collect your special requests as far as what you want to see at the next meeting, whether it be a particular speaker from a CATIA-based company, or whether it be a particular challenge you're having at work. That's how we really construct these agendas, from your insights. As you saw earlier, Tony has done a series of great presentations for us. Really appreciate Bob Hello and Tony Romero for doing that on a regular basis. You know there's no doubt that CATIA is continuing its support both on the version 5 and version 6 level. The version 5 level, they made a public commitment through 2025. So no problem if you have programs that are going to be requiring CATIA version 5 on an ongoing basis, no problem. We do encourage you though to explore version 6 capabilities, not only for CATIA, but also for Innovia, Delmia, Simulia, and the many other elements of the Dassault Systems platform. Based on the survey we did earlier, based on the survey we did earlier, do you have your laptop?
It's powered down.
Okay. Based on our survey from the last meeting, you told us you wanted not only the compatibility between version 5 and version 6, but you also told us that the majority of you had a CATIA configuration by the name of HD2 or Hybrid Design 2. Show of hands, how many people currently know their licenses and they have HD2? Okay, how many people have one level lower than that, MD2, Mechanical Design 2? Okay, so the majority of you have HD2. HD2 is the prerequisite. It has some of the core functions that are required for this next presentation. Thank goodness that's coming up. It's a little bit of a tongue twister, but I think Paul Labadie, who's next online, is going to make better sense of it than I could. This is CATIA Digitized Shape Editor, Quick Surface Reconstruction, and Realistic Shape Editor. Very powerful capabilities with the prerequisite of CATIA HD2, and Paul, correct me if I'm wrong, as well as some additional capabilities that he'll tell you how to get, whether it be just a simple add-on license or whether it's more efficient to take on a different configuration. Also make sure that you mark on your calendars June 28th. Well, and some of you have calendars out here. So that's August 21st for Glaco, September 12th for Western Michigan User Group, and then even sooner in 2 weeks, June 28th at the Birmingham Athletic Club. It does require a reservation, even though it's free of charge. We have to plan the catering, of course. So make sure that you mark June 28th at the Birmingham Athletic Club. We'll make sure to give you further information by either emailing me or jacqueline.murphy.com. All right, as you pull that up, which it should be up now, super, enable the contact up. Hopefully it'll enable your videos. And then just go down to the bottom, and it should be open. You can have to reboot. PowerPoint icon, there you go. Okay, you just have to open it from the desktop then. So it's right on the desktop. Just go to the desktop and double click on that. Hopefully you recognize yours. Is it the LTU? Second column? Down? Perfect. And all the APIs are in this folder, so you should be good to go. All right, I'll put tap fencing then. Make sure you do get your digital copy of Contact Mag. I'll be glad to send that to you. Without further ado, Paul Labadie from Dassault Systems. Let's show him a warm welcome.
Sorry about that. Remember Tony's opening comment about, knowing the icons and knowing where things are at? I'm not a Windows 7 person yet. I'm a Windows XP person. Who'd think you could take the whole thing down with one click? Apologize for the delay. I'm going to talk about the 3 different workbenches: Digitized Shape Editor, and Quick Surface Reconstruction, and Realistic Shape Optimizer. And there's one tool that helps tie those together, and hopefully I'll make that clear while we're doing it. Also, I have my grandkids to thank for a cold, so hopefully I'll be understandable while I'm inside my head. It's kind of echoing. We'll move to the next one here. These are some of the results, some of the files that I've worked with customers over the years, some of the things that we've accomplished or worked on. When we talk about Digitized Shape Editor, we're talking about scan data. In the top left-hand corner, a lot of people look at that and say, that's not scan data, it's a picture of a part. I've even got the chrome on the shaft and the black on the piston. That's scan data. That's seconds after scanning, putting it in the computer, and it's math data. We can cut sections through it. We can make drawings on it. We can annotate it. We can capture that part right from the parts store in just minutes. Okay, if we move over here to the bottom right corner at the bottom, a lot of people don't think that's scan data. It's just a different type of scan data. It's sectional scan data. Okay? And some of the tools that we talk about when we talk about Digitized Shape Editor is the ability to filter the data, to find the sharper edges, as we have right in the center of the screen, the flex front end. And in the bottom of the screen, we've got 2 scans. We have one on the left that looks more dense, one on the right that's less dense. A lot of times the people that are doing the scanning will get too carried away and we'll end up with terabytes of data that is just too dense. We want to be able to filter that down and make it easier to work with. In the bottom left-hand corner, we're actually comparing some scan to some actual surface data. And you can see where the two overlay each other. Typically, when you've got a clay model and you scan it, it's going to have waves in it. And you want to build the smoothest, flattest possible surface through that type of data. Another reason for scan data that I didn't throw up here is in stamping tooling. A lot of times by the time the bench hands get done with the stamping tooling, so they can get the part out of the tool without the splits and the cracks and everything else happening, there's so much hand working done that there is no math data available. And stamping tools wear out. So now we have the problem of how do I capture the math data if I have to make another one? And eventually you will have to make another one if it's a long run. Okay? So there's a lot of reasons that we may want to look at scan data. I can also tell you that one of the busiest times of the year in the OEMs and Ford, Chrysler, I mean, I'm in the Chrysler, the basement of the world headquarters right now. I swear I see as many competitive vehicles driving up and down the aisle as I see Chrysler vehicles driving up and down the aisle. And they're all headed for being scanned or analyzed for one reason or another. And everybody does it. Okay? So these are some examples of the types of things you can do with digitized shape editor. And if we move to the next page, this is how quickly you could get data into your computer. It was a hand scanner. Directly into CATIA. I saw this happen at Dearborn Tool and Die. I was amazed. Just the guy threw a part on the table, walked up, hand scanned it, and there it was graphically. Math data, three-dimensional math data. Okay? How does this fit together? Typically, we're thinking of DSE, the digitized shape editor, as what do I do with the scan data? If I want to edit it, manipulate it, massage it, going from that into quick surface reconstruction. Once I've got the data smooth the way that I want to cut sections, build curves, build surfaces. And after QSR, there is an option to go into RSO. And we'll talk about that later. It's Realistic Shape Optimizer. And these are how the pieces could fit or flow together. Okay, definitions. Some people say reverse engineering. Well, big term. What does that really mean? Any work done with a cloud of points? Well, maybe it's not a cloud of points. Maybe it's sectional data. Maybe there's another way to get there. And we're going to talk about some of that in a little bit. In the bottom left-hand corner, the green one, that's importing points only. A lot of times you don't want all the facets. By facets, what those are, for those that don't know, it's a little triangular surface between the three closest points. Almost like an FEA model, except they're only triangular facets. Sometimes I choose to only bring in the points. If I'm going to be massaging it and cleaning it up anyway, why bring the facets? I'll bring in only the points, and I'll add the facets later. You can cut sections through points or facets. The one in the middle has the facets, so I can shade that. Okay? There's other places that you can get this type of data. In the bottom right-hand corner here, with the DMU wrapping, if you take a part and you wrap it and put cellophane around it so you're not giving somebody else all the internals of your part, that's a mesh. And in the upper right, if you do any kind of animation and you want to have the swept volume or the wheel jounts stored, again, that's a faceted model. So there's other places you can get this type of data from. How do you get it into the system? In the top left-hand corner, you've got the standards of ASCII and IGES and STL that I can read these point clouds in or the scan data and bring it directly into CATIA. Or we have special partners create form. There's also some other custom formats in the top right-hand corner. It's kind of like post-processing for a machine, but in reverse. We want to be able to read these different formats so we can bring that data directly into CATIA. Okay? Here's some examples of digitized shape editor. I threw up some of these earlier, but in the top left-hand corner, when you're scanning panels, you're scanning parts, you're scanning tooling, unfortunately, you can't stop that light if you're using a light scanner from going down into the holes. Well, you really don't want that. You probably want to cut that area out. So you have the ability to edit these clouds and you can remove points. The filtering in the center, again, we use the flex again. I could have that as a homogeneous filter. I could just have a point every 3 millimeters or every 6 millimeters. Or I could tell it I want more points where I have a denser mesh. Or, I'm sorry, I have more curvature. So if I have more curvature, I want more points. You may have in the middle example where it looks like there's spots or dirty spots. Those are places where I've got extra dense mesh that I don't want. I want it nice, smooth, filtered out. The bottom one here is the decimate. The bottom left-hand corner, when I bring in this data, when I started working with Dearborn Tool and Die and we brought in dies, because of the way they were doing it, we were getting all the surrounding data outside of what we really wanted. So having that bounding box, and while I'm bringing in the data, being able to use that box to clip out what I don't want, greatly reduces the data right from the get-go. Okay? So that bounding box is very, very powerful for bringing in the data. In the bottom right-hand corner, filling holes. Typically, you're going to have holes. If it didn't come in with holes, maybe you cut them out with the tool in the top left-hand corner. But you want to be able to fill in those holes, and you can have it filling in tangentially. So if it's got shape to it, the hole will be filled in with a shape, not just a flat. Okay? And in the top right, you may not want to work with a whole area. You may want to use curves to section out an area you want to work with. You may want to do just draw a polygon box around an area you want to work with, or use a paintbrush to highlight an area you want to work with. Only have on the screen what you want to work with, what you want to smooth or play with at that moment. Okay? So these are some graphic examples of, a more involved list of some of the options. You can import the cloud of points, optimize, create the mesh, optimize the mesh by decimating it, make it easier, cleaner, enhance the mesh, smoothing it, removing sharp edges. There's a nice little thing I like to do with a little bunny rabbit that's got all kinds of bumps and lumps. I've got like an iron. I can work that on the bunny rabbit and give him a nice smooth coat. So I can smooth out wrinkles and sharp places in a mesh. Analyze the mesh, find out how it compares to something else. That deviation analysis command is extremely powerful. We're going to cover that in a section all by itself a little later. Okay, so you can also create scans, section your scans, merge scans, sew scans. More importantly, you can align scans. So when you bring in that data, we have tools to help you map that to other geometric data. So if you want to compare it or measure it to other data. Okay, this is the digitized shape editor package. The arrows on the right, the blue arrow, that's all the DSE commands. It does share some of these commands with quick surface reconstruction. So these two workbenches do overlap just a little bit. Okay? Here's some examples of quick surface reconstruction. In the middle, the purple, you've got a part that may have some areas that have sharper boundaries. In the automotive, we call them highlight lines. I want to have the computer help find that for me. Or if I want to find an area on a surface based on slope, I can have it create these curves for me automatically. While I'm doing the far left there in the bottom, the facet surface display, while I'm mapping my cloud to my surfaces or creating my surfaces, I can also display the porcupines and the other tools that we have for checking the quality of the surface while I'm building it. There's an automatic surface tool. And while that looks like a very, very simplistic example, I had a case at Ford Motor Company in the powertrain group where they gave me a exhaust manifold, inside and outside, the whole thing, one piece as a cloud. I did it as one command, one surface, and I even got the product number that was stamped on the side of the part. So you can do some very nice automatic surface creation from the scan. You may have to wait 5 minutes if you did the whole exhaust manifold is quite large, and I really tightened up the tolerance so I could get the stamped number and everything on it. Okay? In the bottom right-hand corner here, we have the power fit command. If I just take that mesh of points or facets and just have on the screen what I want to have a surface through, I can just throw a surface right there. Or I can build nice smooth curves through different areas, and then I can fit the surface through the curves against the mesh. So there's a lot of things you can do to help build these surfaces. Or in the top right-hand corner, if you want to build curves right on the mesh and smooth them, and build a network of these. And then I can generate what's on the right, which is individual surface patches, and I can control the tangency or non-tangency between those meshes. Okay? So these are some tutorial examples of what comes with the quick surface reconstruction. If we go through the actual commands, again, you can create the scans, cut sections through it. While you're doing that, you can just get string data, or you can actually create nice smooth curves. Get your characteristic lines, whether by slope or curvature. Create surfaces from this data, either using a basic surface recognition. What that means is an example of the shock absorber. If I eliminate the scan back to where I'm only looking at cylinder type data, I can actually have CATIA put a cylinder right in there. And it'll be a CATIA cylinder that has all the parameters. So if it comes up with 3.99999, I can change the parameter to 4 and be done. So in the case of something that has piston shape, planar shape, basic types of shapes, I can very, very quickly capture that as fully parametric geometry right from the scan data. So that's basic surface recognition. And then you've got the power, fit, and fill, the automatic surface, and the surface network. And again, the analysis tools, the deviation analysis, this is in both the DSC and the QSR. This is one of the overlaps. And this is the one we're going to spend time on more in depth in a few minutes. That few minutes being right now. This command came out around 17 or 18. By the way, I didn't point out at the beginning of the presentation, everything I'm talking about is available in 18. Every one of these packages has enhancements above and beyond what we're talking about today. But I'm aware of a lot of our current customers are on 18. So if I start the presentation at this level, we can show you what's been added at a later date. But this you can take home today, use today. Okay? Deviation analysis. You can measure between that scan and a surface. You can get point pictures in the center that'll show you the color, and it'll show you this color bar on the right. And you can look at that very quickly and see just exactly where it's deformed or by how much it's off. This is very, very powerful when you get into stamping data. Because if you want to pull a whole area of a panel, you know about how big that area is. And this display stays there. So you can actually use it to draw around or use. Or better yet, what we'll get into later, is actually use this data to change the geometry, alter the geometry. We also have texture mapping, which is on the far left. I can tell you right now, some of the images I've seen in the past of how this is done in the past is by going in and taking point measurements and having a picture that's actually 36 different pages of a bunch of annotation of where every little point is off and by how much. This is so much faster and easier to be able to see where my panel warped from the stamping process, or if I want to compare it to a design. Okay? Along with the deviation analysis, you have the different ways of that color bar. You can control the range of the display, the colors of the display. You can change the accuracy, the feedback that you're getting from it. After you've done one of these deviation analyses, you can actually go in and annotate it as well. So you can actually go in and record where these different locations are off and by how much. Okay? You can also generate a report and export the report. Okay, realistic shape optimizer. This is the third tool that we're going to talk about, the third workbench. And what this is for is turning surface data, solid data, into like moldable clay. And how do you want to mold it? Okay? There's three different ways that I can mold that. I can do it with what's called a displacement field down in the middle of the screen, or deviation analysis. That's that command that exists in both DSC and QSR, or by using a CAE analysis. Okay? And at the bottom I'm putting out that it does work with surfaces or solids. Single part or assemblies. And it doesn't share any commands with DSC or QSR, but it uses some of the capabilities of DSC and QSR. Okay? When I first started working with Realistic Shape Optimizer, we were working with this displacement map. It's X, Y, and Z, and then a delta X, delta Y, and delta Z. And these are some of the images that we worked with back in Rev 16, Rev 17 on CATIA. If you look at the panel in the top left-hand corner, that's the panel that we wanted to alter. And there's tangencies, it's one surface, but we have all the tangencies and the smoothness that's in there. And then the right, it looks like two finite element models, and one has been distorted. The word that the vendor chose to use was disturbed. You have the regular mesh, and then you have the disturbed mesh. And they had their calculations for how they thought the panel was going to alter under the stamping operation. And what they wanted to do is they wanted to take the difference between those two and map it into a change in the surface. When the command first started out, we were actually picking one CAE, picking the other CAE, and generating this displacement map. But then they got down to where we were actually creating their own displacement map. And it's just a text file. So if you have your own way that you want to create this text file that has the XYZ and then the delta XYZ, you can take what's on the top left and generate what's in the bottom right, which would be a closer example to how you expect that panel to come out of the stamping tool. So when it releases, it springs back into the position that you wanted to begin with. Deviation analysis. I've got different names up there for different colors, but the important thing of the whole slide is this side over here, where I had the product was in the middle here, and I had the scan. It came back and it told me that when this panel came out of the tool, that part of the panel sprang up. Well, how much? I have to go in and measure it, right? Well, what if I just did a scan, brought it back in, did a deviation analysis between the scan and the product? That's going to give me a measurement for, a couple of 100 points in that area. Well, what if I now could use that to distort the original surface in the opposite direction and scale it? Okay, so what I'm talking about is when the panel comes out of the tool, I know I'm going to have to alter it again. And I'm going to have to alter it by maybe 1.3 times the distance that it's off, because it's going to spring back that much. There's always a percentage add. Okay, so by using the deviation analysis, I can actually morph from the original product using the deviation analysis and come up with a new product that's scaled and in the opposite direction. So now when it comes out of the tool, it should come back in the exact right position. Okay. This deviation analysis, I pointed out in one of the first slides. Actually, I don't think I did point it out. My bad. It's not just measuring between scan data and a surface. It's not just measuring between two surfaces. It's also not just measuring between two sets of scan data. I can actually measure between a point and a scan, a point and a surface, between two lines. Okay? And given that flavor, I had a little fun with this. I created a line here, and I took that line and I moved it off into space. There's also two lines here on top of each other, two lines on top of each other there, a line there, an offset line there, and I've got a line in the front that I offset. Look at the size of this assembly. All solid parts. One deviation analysis command to measure the distance from that line to that line, from that line to that line. These two lines are on top of each other, these two are on top, but that one's offset again. So once I've done the deviation analysis, which just takes seconds, I can then use that to alter all of that into this. And it creates one part for each part, one solid for each solid. And no, you wouldn't want to do this yourself, because look what I did to my poor little handle. You probably wouldn't want to include your handles and your knobs when you did this. But I just took a whole seat, springs, the whole works in one command. In less than 5 minutes, I generated a completely new assembly with everything stretched, scaled, and altered the way I wanted it to fit in a particular area. A little wild, a little crazy. Okay, analysis, being able to take in those distances between, again, from the wing. I'm sure we've all flown at one time or another and you've seen the wing wiggling in space, finding out how it's going to distort. But CAE, the CAD analysis, is another way, and I'm going to show an AVI on how this is done and what was picked. It's going to be this example here. But the CAE analysis can be used to alter the geometry as well. And where that comes into play, and where a lot of this comes into play, is a lot of times it's not the part that we're planning to build, it's the part that's under load or under stress, or the part that gets sat in. What does it look like at that point? That's where I want to check my clashes and my interferences. I want to check it as built and also as under load. So this is a very quick way of getting that under load part. Okay, we're going to get into our demonstrations here. When I get into the demonstrations, it's going to be a movie running in the center of the screen. And on the right hand of the screen, I'm going to have the steps that are going to be run through in that part. I don't want to try and talk through it. I'd like you just to watch the AVI. And every step is captured. And where I've edited for time, I'll let you know. When you hit the update command, that reads in the file. That also brings up that bounding box. If you don't want to work on the whole car, you just want to work on the door, how do you quickly throw away all the other data? Better yet, don't even bother bringing it in. Remember that quick editing for adaptive? It happens this quick, by the way. Very powerful. There's two ways to turn off points. One is to actually delete them out of your file. This is saying I only want to activate, and I'm using the polygon. As you can see, there's a lot of other options on the panel. The rest of those points are still there. They're just more or less blanked. Going to the quick surface reconstruction workbench, and I'm going to put a surface through that mesh. Now we're going to bring back the rest of the points. This is probably a needless step. I haven't seen a lot of customers taking their solids or their faces and offset them to get thickness yet. I've seen a few of them playing with the idea, but that's just part design. Okay, that's one example of how you can quickly get to a surface from a scan. Just bring it in, limit the area you're looking at, filter it, throw a surface in there. This next one is to go to a solid. What's going to be unique about this is the fact that there's the capability to create a CATIA sketch right from section data through a scan. And yes, it's a brake caliper. Got to cut two sections through the beginning. For the top of the part, I wanted to turn off most of the mesh. If you remember, I said earlier that when you turn it off, you're hiding it, that whatever you're doing to it, it doesn't take what's hidden into account. So if I wanted to create a planar section through that top area, I didn't want to catch the rest of the part. And you can always bring the rest of it back if you want. And now we're going to take one of those sketches and turn it into, one of those planar sections, and we're going to turn it into a sketch, a continuous sketch. And you're going to see in this tool the ability to control where I have my tangencies. You're also going to see in this tool that I can ask for primitives. It may be a spline, but I want to put an arc in. It may have come out wavy enough that it wants to put a spline in, but I can force a line. So I can control what type of geometry ends up in the sketch and where the tangencies are. Or I can let it automatically default to what it thinks is best. And you got lines, circle, ellipse, different choices, different options. This becomes a regular CATIA sketch as if I had done it in CATIA myself without the scan. But I'm using the scan data. which of course I can then take into part design and turn into a solid. And we're going to see a little demo magic after this, because if we saw one done, we don't need to see a second one done. So a quick thought-provoking thing for you. If I'm in the business of making these parts, and I didn't get selected to make this part, so I stop at AutoZone and grab one and get a hand scanner, how long before I'm making this part? And I know it'll fit, right? Pretty accurate. It's math data. Okay, this is the airplane wing that I talked about. And there's a stage in this where you're going to pick the geometry that you want to alter. This is an example of the RSO. And then you're going to pick what's going to drive it, and it's going to go and create this displacement map. It's going to ask you for the name of that, excuse me, the name for the displacement map. I've already got the picture in the bottom left-hand corner. The displacement map is that XYZ IJK. So working from the analysis, it creates a displacement map for you. Let's pick the screen, watch the movie. So here I'm going to pick 3 sets of geometry. In the case of the car seat that I did earlier, I just windowed everything. Here I'm going to pick, instead of a displacement map, I'm going to pick a CAE analysis. It asks me for a file name so I can write it out. And then there's a little bit of demo magic here. Even at a tolerance of 5 millimeters, it takes 2 or 3 minutes. At a 0.1, it took about 10 minutes. So this is only going to take about 30 seconds. But here I'm going to see the wing in its deformed state based on analysis. And this is actual 3D math data. I can do clashes, check for clearances. You know, everything that we're doing with this DSE, QSR, or RSO, it's all math data. It's machinable data. I can dimension it, cut sections through it. Okay? At that point, I guess I would ask if there's any questions. Is anybody using this today? One? Where are you from? Ford. So you know Lloyd Vandenbrink? You know Lloyd Vandenbrink? Yeah. Nice guy, super guy. Yeah, for those that don't know, this is a very, very iterative process in the studios. They scan it, put nice smooth surfaces through it. They only ever deal with half the vehicle. So of course, that center line is an issue. You have to mirror the surfaces and then check them for tangencies and whatever. And again, the surfaces are used for machining, and sometimes they'll use scan data for machining. But it's an iterative thing, you know. Scan it, sweeten it, machine it. Don't like it, put some more clay on it and do it again. Lots of fun.
Paul, at the last meeting, many of our members were asking about the prerequisites for a lot of capabilities to demonstrate. And maybe you've already covered this, but if you could reiterate what they would need within CATIA in order to have this capability.
DSE and QSR are pretty much standalone. You're just bringing those into native CATIA. Anything that you've got.
MD2 or MD2 and version 5?
No. No, for RSO, you've got to have GSD, though.
Okay. And
Generative shape design.
Generative shape design is part of HT2. Many of our members have told us that they have a conglomerate of licenses, but they're not quite sure what capabilities are in that conglomerate. And we're going to try to help you every meeting to show you some of the capabilities you may not realize you already have, and those that you can advance to with your current prerequisites. Question over here? Yes, sir.
I had a question. Your surfacing capabilities, how does it compare to a tool like ISOMSurf, where they do zebra stripes and all that stuff to make sure that the surfaces are...
Well, ISOM and CATIA are one and the same now, aren't they? I mean, there are still, the ISOM workbench has some different tools. The CATIA workbench also has zebra striping. which one you feel is better, which one you prefer to use. I mean, that would be your choice.
So this is what the OEMs are using to do the surfacing?
What are you using in the studio when you use the surfacing? Are you using CATIA or using ISOM?
Combination of original ISOM and CATIA-based ISOM, designs from Alias, increasing to quality of surface, they are quality standard.
Yep.
It's going to be input dependent, right? So if you're surfacing, you're automatically surface the scan, it's going to have slightly different quality than some sat down and actually quality, using sweeps and curves, something like that. I don't think that this has been that whatever, there's some putting the hand on the surface and creating it. So that's what you're asking.
Well, I've seen the tool, the ISOCERT tool, used by an expert in we get to a Class A surface. And I just wondered, at that point in time, I don't think this tool is capable of that.
Well, actually, CATIA Surf does have, like you say, the zebra striping and whatnot. I also have a lot of tools for comparing and doing analysis of the actual quality. But ISOM Surf, you know, used to be a competitor, but now it's under my arm. We also have Andre. Do you want to? Andre is a Class A surfacing expert.
Yeah, actually, there's ISOM Surf standalone that we create, as well. And then there's CATIA ISOM. So there's a version of ISOM inside of CATIA that actually works inside of CATIA interface and the workbench. And it gives you, actually, we use the same mathematics to generate the geometry in both. So we have made with this release that Paul's working on and showing you there's actual functional parity between CATIA ISOM and ISOM Surf. So there is a difference between the surfaces that he's showing you. That's for rapid surfacing. For quick surface, so when you need to surface back really fast. Obviously, the ISOM or CATIA ISOM process is going to be a little bit slower, but the quality level is higher as a result. So that's what you want to do. You want to final, finish, production, exterior data, Class A.
Even long before the ISOM merger, if you want to call it that, we had something called freestyle and generative shape design. So we had more than one surfacing tool. You know, one of them was geared to what I call the point pullers, the people that want to be able to pull different polygon points different ways. Generative shape design is not a point pulling software. But like Andre said, what we're talking about today is how do I get from scan data, or if you look at all these pictures on the wall, most of them were at clay at some point in time, or like the stamping tools. I want to preserve that intelligence, or I want to be able to make that die again even though it's been benched to death. Okay, how do I capture all that math data? There's lots of places where DSE and QSR can be used for saving that data, getting the data, building surfaces or geometry through the data. Okay, if I'm doing Class A, yeah, maybe I'll look at something a little higher up.
And regarding zebra striping or reflex curve analysis, there is the core capability in CATIA, some of their advanced modules as well as CATIA ISOM Surf. We introduced Ray Clemens, one of the best in the country at CATIA and ISOM. We also have our client manager, Phil Bouchard, who's hosting the afternoon at CATIA Designers Cafe. He'll be glad to capture any other questions or requests you have and get in touch with any expert you need.
Okay.
Additional questions for Paul? If not, a warm round of applause.